Class 10th, Chapter 1, Real Numbers. 1.6 Summary. In this chapter, you have studied the following points. 1. Euclid's division lemma. Given positive integers a and b, there exist whole number q and r satisfying a is equal to pp plus r. 0 is lesser than r is lesser than b. 2. Euclid's division algorithm. This is based on Euclid's division lemma. According to this, the HCF of any two positive integers a and b with a greater than b is obtained as follows. Step 1. Apply the division lemma to find q and r where a is equal to bp plus r. 0 is lesser than r is lesser than b. Step 2. If r is equal to 0, the HCF is b. If r is not equal to 0, apply Euclid's lemma to b and r. Step 3. Continue the process till the remainder is 0. The divisor at this stage will be HCF AB. Also, HCF AB is equal to HCF BR. 3. The fundamental theorem of arithmetic. Every composite number can be expressed factorized as a product of primes, and this factorization is unique apart from order in which the prime factor occurs. 4. If p is a prime and q divides a square, then p divides a where a is a positive integer. 5. To prove that root 2, root 3 are irrationals. 6. Let x be a rational number whose decimal expansion determinates. Then we can express x in the form of p by q, where p and q are co-primes, and the prime factorization of q is of the form 2n 5m, where n m are non-negative integers. 7. Let x is equal to pq be a rational number such that co-factorization of q is of the form p2n 5m, where n m are non-negative integers. Then x has a decimal expansion which determinates 8. Let x is equal to p by q be a rational number such that the prime factorization of q is not of the form 2n 5m, where n m are non-negative integers. Then x has a decimal expansion which is non-terminating, reoccurring. A note to the reader. You have seen that HCF PQR multiply LCM PQR is not equal to P multiply Q multiply R, where PQ are positive integers. See example 8. However, the following results hold good for three numbers P, Q and R. LCM PQR is equal to P multiply Q multiply R. HCF PQR by HCF PQ multiply HCF QR multiply HCF PR. HCF PQR is equal to P multiply Q multiply R multiply LCM bracket open QPR bracket close. LCM PQ multiply LCM QR multiply LCM PR. Chapter 2, Polynomials. 2.5 Summary. In this chapter, you have studied the following points. 1. Polynomials of degree 1, 2 and 3 are called linear, quadratic and cubic polynomials respectively. 2. A quadratic polynomial in x with real coefficients is of the form ax square plus bx plus c, where a, b, c are real numbers with a is not equal to 0. 3. The zeros of a polynomial px are precisely the x-coordinates of the points where the graph of y is equal to px intersects the x-axis. 4. A quadratic polynomial can have at most 2 zeros and a cubic polynomial can have at most 3 zeros. 5. If alpha and beta are the zeros of quadratic polynomial ax square plus bx plus c, then alpha plus beta is equal to minus b by a, alpha beta is equal to c by a. 6. If alpha, beta, gamma are the zeros of a cubic polynomial ax cube plus bx square plus cx plus d, then alpha plus beta plus gamma is equal to minus b by a, alpha beta plus beta gamma plus gamma alpha is equal to c by a. and alpha beta gamma is equal to minus d by a. 7. The division algorithm states that given any polynomial px and any non-zero polynomial gx are polynomials qx and rx such that px is equal to zx multiply qx plus rx, where rx is equal to 0 or degree rx is lesser than degree gx. Chapter 3. Pair of linear equation in two variables. 3.6 Summary. In this chapter, you have studied the following points. 1. Two linear equation in the same two variables are called a pair of linear equations in two variables. The most general form of a pair of linear equation is a1x plus b1y plus c1 is equal to 0. a2x plus b2y plus c2 is equal to 0, where a1, a2, b1, b2, c1, c2 are real numbers such that a1 square plus b1 square is not equal to 0. a2 square plus b2 square is not equal to 0. 2. A pair of linear equation in two variables can be represented and solved by the 1. Graphical method, 2. Algebraic method. 3. Graphical method. A graph of a pair of linear equation in two variables is represented by two lines. 1. If the line intersect at a point, then the point gives the unique solution. If the two equation, in this case the pair of equation, is consistent. 2. If the line coincide, then there are infinitely many solutions, each point on the line being a solution. In this case, the pair of equation is dependent, consistent. 3. In the lines, if the lines are parallel, then the pair of equation has no solution. In this case, the pair of equation is inconsistent. 4. Algebraic method. We have discussed the following methods for finding the solutions of the pair of linear equation. 1. Substitution method. 2. Elimination method. 3. Cross multiplication method. 5. If a pair of linear equation is given by a1x plus b1y is equal to 0 and a square x plus a2x plus b2y plus c2 is equal to 0, then the following situation can arise. 1. A1 plus b2 is not equal to b1 by b2. In this case, the pair of linear equation is consistent. 2. A1 by A2 is equal to B1 by B2 is not equal to C1 by C2. In this case, the pair of linear equation is inconsistent. 3. A1 by A2 is equal to B1 by B2 is equal to C1 by C2. In this case, the pair of linear equation is dependent and consistent. 6. There are several situations which can be mathematically represented by the two equations that are not linear to start with, but we alter them so that they are reduced to a pair of linear equations. Chapter 4. Quadratic equation. 4.6 Summary. In this chapter you have studied the following points. 1. A quadratic polynomial in the variable x is of the form ax square plus bx plus c is equal to 0, where a, b, c are real numbers and a is not equal to 0. 2. A real number alpha is said to be root of quadratic equation ax square plus bx plus c is equal to 0 if quadratic equation ax square plus bx plus c is equal to 0 are the same. 3. If we can factorize ax square plus bx plus c, a is not equal to 0, into a product of two linear factors, then the roots of a quadratic equation ax square plus bx plus c is equal to 0 can be found by equating each factor to 0. 4. A quadratic equation can also be solved by the method of completing the square. 5. Quadratic formula. The roots of quadratic equation ax square plus bx plus c is equal to 0 are given by minus b plus and a minus root b square minus 4ac by 2a, provided b square minus 4ac greater than 0. 6. A quadratic equation ax square plus bx plus c is equal to 0 has 1 two distinct real roots if b square minus 4ac greater than 0. Two equal equation example consists the constant roots if b square minus 4ac is equal to 0, and no real roots if b square minus 4ac is lesser than 0. A note to the reader. In case of word problems, the obtained solution should always be verified with the condition of original problem and not in the equation formed. In example 11, 13, 19 of the chapter 3 and example 10, 11, 12 of chapter 4. Chapter 5 Arithmetic Progression. 5.5 Summary. In this chapter you have studied the following points. 1. An arithmetic progression AP is a list of numbers in which each term is obtained by adding a fixed number D to the preceding term except the first term. The fixed number D is called the common difference. The general form of an AP is A plus D, A plus 2D, A plus 3D and so on. 2. The given list of numbers A1, A2, A3 is an AP if the difference A2 minus A1, A3 minus A2, A4 minus A3 and so on give the same values. Example, if AK plus 1 minus AK is the same for different value of K. 3. In an AP with first term A and common difference D, the nth term or the general term is given by an is equal to A plus bracket open n minus 1 bracket close D. 4. The sum of first n term of AP is given by x is equal to n by 2 2a plus n minus 1 multiply D. 5. If L is the last term of the finite AP, say the nth term, then the sum of all terms of the AP is given by S is equal to n by 2 A plus L. A note to the reader. If A, B, C are in AP, then B is equal to A plus C by 2 and B is called the arithmetic mean of A and C. Chapter 6 Triangles. 6.7 Summary. In this chapter, you have studied the following points. 1. Two figures having the same shape but not necessarily the same size are called similar figures. 2. All the congruent figures are similar but the converse is not true. 3. Two polynomials of the same number of sides are similar if 1. Their corresponding angles are equal and 2. Their corresponding sides are in the same ratio. Example, proportion. 4. If a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, then the other two sides are divided in the same ratio. 5. If a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. 6. If in two triangles corresponding angles are equal, then their corresponding sides are in the same ratio and hence the two triangles are similar. Similar criterion. 7. If the two angles of the triangle are respectively equal to the two angles of the other triangles, then the two triangles are similar. Similar criterion. 8. If in two triangles corresponding sides are in the same ratio, then their corresponding angle are equal and hence the triangle are similar. SSS similarity criterion. 9. If one angle of triangle is equal to one angle of another triangle and the sides including these angles are in the same ratio proportional, then the ratio are similar. SAS similar criterion. 10. The ratio of areas of two similar triangles is equal to the square of the ratio of their corresponding sides. If a perpendicular is drawn from the vertex of the right angle of a right triangle to the hypotenuse, then the triangles on both sides of a perpendicular are similar to the whole triangle and also to each other. 12. In a right triangle, the square of the hypotenuse is equal to the same of the square of the other two sides. Pythagoras theorem. 13. If in a triangle square of one side is equal to the sum of squares of the other two sides, then the angle opposite to first side is a right angle. A note to the reader. If in two right triangles, hypotenuse and one side of one triangle are proportional to the hypotenuse and one side of the other triangle, then the two triangles are similar. This may be referred to as the RHS similar criterion. If you use this criterion in example 2, chapter 8, the proofs will become similar. Chapter 7. Chapter 7. Chapter 7 Coordinate Geometry. 7.5 Summary. In this chapter you have studied the following points. 1. The distance between P, x1, y1 and Q, x1, x2, y2 is root bracket open x square minus x1 whole square plus y2 minus y1 whole square. 3. The distance of a point P xy from the origin is root x square plus y square. 3. The coordinates of the point P xy which divides the line segment joining the points A x1 y1 and B x2 y2 internally in the ratio m1 m2 are m1 x2 plus m2 x1 by m1 plus m2, comma m1 y2 plus m2 y1 by m1 plus m2. 4. The midpoint of the line segment joining the points P x1 y1 and Q x2 y2 is x1 plus y2 x1 plus x2 by 2 y1 plus y2 by 2. 5. The area of the triangle formed by the points x1 y1 x2 y2 and x3 y3 is the numerical values of the expression 1 by 2 x1 bracket open y2 minus y3 bracket close plus x2 bracket open y3 minus x1 bracket close plus x3 bracket open x1 minus y2 bracket close. A note to the reader. Section 7.3 discusses the section formula of the coordinates xy of a point P, which divides internally the line segment joining the points A x1 y1 and B x2 y2 in the ratio m1 ratio m2 as follows. X is equal to m1 x2 plus m2 x1 by m1 by plus m2, comma y is equal to m1 y2 plus m2 y1 by m1 plus m2. Note that here PA ratio PB is equal to m1 ratio m1. However, if P does not lie between A and B but lies on the line AB outside the line segment AB, and PA ratio PB is equal to m1 minus m2, we see that P divides exactly the same segment joining the point A and B. You will study section formula if such cases in higher cases. Chapter 8 Introduction to Trigonometry. 8.6 Summary. In this chapter you have studied the following points. 1. In a right triangle ABC, right angled at B, sin A is equal to side opposite to angle A by hypotenuse. Cos A, side adjacent to angle A by hypotenuse. Tan A is equal to side opposite to angle A by side adjacent to angle A. 2. Cos A is equal to 1 by sin A, sac A is equal to 1 by cos A, tan A is equal to 1 by cot A, tan A is equal to sin A by cos A. 3. If one of the trigonometric ratios of an acute angle is known, the remaining trigonometric ratios of an angle can be easily determined can be easily determined. 4. The values of trigonometric ratios of angles 0 degree, 30 degree, 45 degree, 65 degree and 90 degree. 5. The value of sin A or cos A never exceeds 1, whereas the value of sec A or where sec A or cosec A is always greater than or equal to 1. 6. Sin 90 degree minus 1 is equal to cos A. Cos 90 degree minus A is equal to sin A. Tan 90 degree minus A is equal to cot A. Cot 90 degree minus A is equal to tan A. Sec 90 degree minus A is equal to cosec A. Cosec 90 degree minus A is equal to sec A. 7. Sin square A plus cos square A is equal to 1. Sec square A minus tan square A is equal to 1 for 0 degree lesser than A lesser than 90 degree. Cosec 2 A is equal to 1 plus cot is equal to cot square A for degree grade lesser than A 0 degree lesser than A lesser than 90 degree. Chapter 9. Some applications of trigonometry. 9.3 Summary. In this chapter you have studied the following points. 1. The line of sight is the line drawn from the eye of the observer to the point in the object viewed by the observer to the angle of elevation of an object viewed as the angle formed by the angle of sight with the horizontal when it is above the horizontal level. Example, the case when we raise our hand to look at the object. 3. The angle of a depression of an object viewed is the angle formed by the line of segment with a horizontal when it is below the horizontal level. Example, the case when we lower our head to look at the object. 2. The height of the length of an object or the distance between two distinct objects can be determined with the help of trigonometric ratios. Chapter 10 Circles. 10.4 Summary. In this chapter you have studied the following points. 1. The meaning of tangent to a circle. 2. The tangent of a circle is perpendicular to the radius through the point of the contact. 3. The lengths of the two tangents from the external point of a circle are equal. Chapter 11 Constructions. 11.4 In this chapter you have learned how to do the following constructions. 1. To construct a triangle similar to a given triangle as per a given scale factor which may be less than 1 or greater than 1. 2. To construct the pair of tangents from an external point to a circle. A note to the reader. Construction of a quadrilateral or a polynomial similar to a given quadrilateral or a polynomial with a given scale factor can also be done following the similar steps as used in example 1 and 2 of construction 11.2. Chapter 12 Areas related to circles. 12.5 Summary. In this chapter you have studied the following points. 1. Circumference of a circle. 2. Pi r. 3. Area of circle pi r square. 3. Length of an arc of a sector of a circle with radius r and angle of degree measure theta is theta by 360 multiplied 2 pi r. 4. Area of sector of a circle with radius r and angle with degree measure theta is equal to theta by 360 multiply pi r square. 5. Area of segment of a circle is equal to area of corresponding sector minus area of corresponding triangles. Chapter 13 Surface Area and Volume. In this chapter you have studied the following points. 1. To determine the surface area of an object formed by combining any two of the basic solids, namely cuboid, cone, cylinder, sphere and hemisphere. To find the volume of objects found by combining any two of a cuboid, cone, cylinder, sphere and hemisphere. 3. Given a right circular cone which is sliced through by a plane parallel to its base, when the smaller conical proportion is removed, the resulting solid is called a frustum of a right circular cone. For the formula involving the frustum of a cone are: one volume of frustum is of a cone is equal to 1 by 3 pi h bracket open r1 square plus r2 square plus r1 r2. 2. Curved surface area of a frustum of a cone is equal to pi l bracket open r1 plus r2, where l is equal to root h square plus bracket open r1 minus r2 bracket close square whole square. 3. Total surface area of a frustum of a cone is equal to pi l bracket open r1 plus r2 bracket close plus pi bracket open r1 square plus r2 square, where h is equal to vertical height of a frustum, l is equal to slant height of the frustum, r1 and r2 are radius of two base ends of the frustum. Chapter 14 Statistics. 14.6 Summary. In this chapter you have studied the following points. 1. The mean of group data can be found by 1. A direct method x under square minus sigma f1 x1 by sigma f1. 2. The assumed mean method x underscore and is equal to a plus sigma f1 d1 by sigma f1. 3. The step division method x underscore is equal to a plus sigma f1 u1 by sigma f1 multiply h, with the assumption that the frequency of class is centered at the midpoint called its class mark. The mode of grouped data can be found by using the formula mode is equal to L plus f1 minus f0 by 2f1 minus f0 minus f2 multiply h, where symbols have their usual meanings. 3. The cumulative frequency of class is the frequency obtained by adding the frequencies of all the classes preceding the given classes. 4. The median for grouped data is formed by using the formula median is equal to L plus n by 2 minus Cf by f multiply h, where symbol has their usual meanings. 5. Representing a cumulative frequency distribution graphically as a cumulative frequency curve or an ogive of the less than type and of the more than type. 6. The median of group data can be obtained graphically as the x-coordinate of the point of intersection of the two ogives for this data. A note to the reader. For calculating mode and median for group data, it should be ensured that the class intervals are continuous before applying the formula. Some conditions also apply for construction of an ogive. Further, in case of ogives, the scale may not be the same on both the axes. Chapter 15 Probability. Summary. In this chapter, you have studied the following points. 1. A difference between experimental probability and theoretical probability. 2. The theoretical classical probability of an event E, written as PE, is defined as P is equal to number of outcomes favorable to E by number of all possible outcomes of experiment, where we assume that the outcomes of experiment are equally likely. 3. The probability of a sure event or certain event is 1. 4. A probability of an impossible event is 0. 5. A probability of an event is a number P such that 0 lesser than P, PE lesser than 1. 6. An event having only one outcome is called a elementary event. The sum of the probabilities of all the elementary events of an experiment is 1. 7. For any event any event P plus P underscore E is equal to 1, where E underscore stands for not E. E and underscore E are called complementary events. A note to the reader: the experimental or empirical probability of an event is based on what has actually happened, while the theoretical probability of the event depends on predict what will happen and the basis of certain assumption. As the number of trials in experiment go on increasing, we may expect the experimental and theoretical probabilities to the nearly the same. Appendix A1 proves in mathematics. Exercise A1.6. 1. Suppose A plus B is equal to C plus D and A lesser than C. Use proof A1. Appendix A1 proves in mathematics. A1.8 summary. In this appendix, you have studied the following points. 1. Different ingredients of a proof and other related concepts learned in class 9th. 2. A negation of a statement. 3. A converse of a statement. 4. Proof by contradiction. Appendix A2 mathematical modeling. A2.5 summary. In this appendix, you have studied the following points. 1. A mathematical modeling is a mathematical description of a real life situation. Mathematical modeling is the process of creating a mathematical model, solving it and using it to understand the real life problem. 2. The various steps involved in modeling are understanding the problem, formulating the mathematical model, solving it, interpreting it in the real life situation, and most importantly, validating the model. 3. Develop some mathematical models. 4. The importance of mathematical modeling. Various types of algebraic expressions. 1. Monomials. 2. Binomials. 3. Trinomials. 4. Quadrinomials. Polynomials. Types of maths. Arithmetic, algebra, geometry. Trigonometry, sine, cos, tan. Calculus, statistics, number theory, linear algebra, differential equation, topology, logic, mathematical physics, theory of computation, information theory, game theory. Theta angle, hypotenuse, adjacent, base, opposite, perpendicular. Some supplementary angles, complementary angles, adjacent angles, linear pair of angles. By using trigonometry, the distance or height can be found. Sine, cosine, tangent, cosecant, secant, cotangent. Thank you.